everyone. We are going to talk about the code behind stock trading simulation. So in the previous lecture, we went through the overview of the program, exactly what the program does, the basic functionalities, the different inputs and outputs, what these buttons do. We went through extensively the learning objectives, the program features. We also did a little simulation, which took a while. And I asked everybody to review the code because the code was available to explore the model on your own. And you should really do that before you go through the solution here. So everything has been available to you, and hopefully you got a chance to go through, explore, try different things, and look at the code, try to figure out if you can figure out exactly how this works. So once you've done that, you will have some ideas and you will have some questions. Then when I go through this code with you, I think hopefully that'll make a little bit more sense. And you'll have aha moments that hope you kind of learn better. Okay, so hopefully you have done your homework and we are going to go ahead and start going through the code. So this program, if we look at the inputs spreadsheet is supposed to be hidden, but I'm going to show it here. And also the model is actually where all the secret recipe of the simulation is actually kind of programmed right here in the spreadsheet. So I'll go through the spreadsheet formulas with you. But let's go behind the scene first to see the VBA code behind the scene. The VBA code actually is pretty straightforward. It is designed to automate the process of repeating the same model 1,000 times or whatever times that the user wants. The VBA code does not actually run the simulation. The simulation is done completely on the front end in the spreadsheet. So the back end really but the spreadsheet on the front end, it only does it one at a time, right? So you run one simulation at a time. And so if you want to do 1,000 runs or even 1,000,000 runs, you will have to do that automation with this VBA code. So that's the whole point of the behind the scene code. Okay, so once we go through the VBA code, then we'll go back to the front end to look at the spreadsheet and the formulas embedded in the spreadsheet. So this application contains a stock trading simulation on the model worksheet. So that's the worksheet that we'll look at after we're done with the VBA code. Details of the simulation are coded into the front end spreadsheet of the model worksheet. Each run of the model worksheet simulates the stock market for 250 days. This application allows the user to repeat the model for up to 1,000 times. The run simulation sub, which is down below, we'll look at that later. That sub repeats the simulation model for the desired number of times that's specified by the user. And that sub does that by using a for loop. So we'll look at how a for loop is used. And we basically just call the calculate method of the application. This is how you redo a model 1,000 times. This forces a recalculation with new random numbers. You see that on the model worksheet and also on the inputs, we have a bunch of random numbers that randomly start the stock market simulation at a given moment, and those numbers need to be recalculated. So these new random numbers have to be regenerated with each run so that we can see variations, right, in the stock market. We can capture, sort of model that, the level of uncertainty and the randomness in the market. The rest of the application is a simple matter of recording selected outputs on a replications worksheet. So this worksheet so far is invisible, so but we will see it after the model has been run. Or maybe not. I don't know if it becomes visible or not, but if it's invisible, we can always make it visible so you can see it. Also summarize them as tables and visualizations for the user. So those are the histograms and also the outputs table. There's some exercises I want you to do after you're done with going through this once. Additional things for you to think about include the following. So for example, you can change the calculation options from automatic to manual or vice versa to see if that indeed influences the runtime of the model. So what does that mean? So if you go to the From page, you can go to I believe is it data? Maybe it's let me try to find it. Home. Here it is. Under formulas, we have calculation options, and then you can do either automatic or manual. Now, if you switch from automatic to manual, your calculation will actually, the simulation will actually run a lot faster. Okay, let's go back to the code, the developer tab. So change the calculation option from automatic to manual, vice versa, to see if that influences the runtime of the model. So that's something you can try after you've gone through the code. Experiment with the same basic buy low, sell high trading strategy, but with different percentages in column J of the input worksheet. So you can mess around with the input worksheet to see how the strategy changes. Can you find any strategies that consistently outperform others? You know, any numbers, input, or settings that will help you optimize the strategy. So that's the beauty of a simulation, that is you can very quickly try a lot of what if scenarios to figure out if something will work without actually having to invest money in stock market. The simulation will tell you exactly what will happen. Now change the basic type of strategy to buy high, sell low. How do you do that, right? So how do you change your strategy? That is, if the price goes up, you buy more shares, whereas if it goes down, you sell. What changes do you need to make to the simulation model in order to implement this strategy? Do you need to make any changes to the VBA code? Does this strategy tend to do better or worse than buy low, sell high? You know, how do you figure these things out? And you can actually do this very easily with a simulation, but the key is you need to know how to use the simulation. All right, so starting with the main sub. Okay, the main sub runs when the user clicks the Run the Simulation button on the simulation sheet or the inputs sheet. So we have two buttons that are equivalent. Either button will take the user to the sub main. The main sub also does the following itself. Get the number of desired replications from an input box from the user, and clear contents from the replications worksheet from any previous run. So let's go ahead and go through the code here. So this is asking, so nreps is the number of replications that the user wants. We're going to get that using an input box. Okay, the user can specify a number that's between 0 and 1,000. So if the user specifies any number that's greater than 1,000, we'll give an error message and we'll loop this through. We'll ask the user again until the user gives us a number that's less than 1,000. Okay, so you can see that, you know, this loop actually does not know how to handle a negative number. So you might get into trouble if the user is tricky and is trying to, sort of test the program by giving a negative number. So this would not capture that. So my challenge for you is to think about how you can prevent the user from entering a negative number using the same loop here. This program, the main sub, also clear previous results. So basically we would choose the replications worksheet and we specify range A3 and we do an entire this section, the offset, to clear contents. We enter the replication counter on the simulation sheet with this code, although I don't think we do that anymore. So, yeah, so I don't think we have to worry about it. However, we do run the simulation and collect the stats. So we call the run simulation sub over here. And we detect the counters and turn off screen updating. So we delete the counters. So we clear some of the content and then we update the application. Screen updating is false. Okay, so this is how we turn off screen updating, just to make sure that the program only shows results from the simulation. We also call collect stats, which is another sub over here that we'll go through later. Okay, and then we delete the replication counter on the simulation sheet. We update the histogram data by calling this routine that we'll talk about later. We show the results on the summary worksheet. So once we have the results, then this was supposed to be a hidden worksheet, but once we have the results, then we make it visible, we activate it, and we select this range over here. And then we unhide the histogram sheets, right? So from 1 to 5, we make all the worksheets visible so that the user can see all 5 histograms. This simulation, the run simulation sub runs the replications of the simulation. The simulation model is already set up on the front end. So all this stuff does is to force a recalculation of the sheet and record the results. So this is looping through the number of applications. So the user has already specified the number of applications. Note that this number of nreps is here used as a global variable. So no matter what sub you're in, this number is always valid. So whatever the user specified over here. Okay, so the user provided an nreps, that value is actually from a different sub. However, because it's a global variable, the value is available within this sub as well. So this is a global, I can actually write this. I could say this is a global variable. I do not recommend using global variables in general. In this particular context, it actually worked fine, but you should pass values whenever you can. So this value can actually easily be specified as a parameter over here, and the value can be passed as part of the function call. But this is done differently here as a global variable. So we can show the current replication number on the explanation sheet. That's over here. So we look for the rep number range, and then we set the value to I, which is the current rep. Okay. And then this is very important. This one little line forces a recalculation with new random numbers. So application is an object, and calculate is a method of application. And this is basically asking VBA to force recalculation within this application. Record outputs on the replication sheet. So with the replication sheet, we choose range A3, and then we basically print all the major outputs that we want to print. So the ending cash, ending stock value, accumulated gain or loss, minimum price, and maximum price. These are the 5 outputs that we're tracking. So we just print them on the replications sheet. This sub collects stats, summarizes the results of all replications of the simulation. So first of all, we loop over the output measures. We have 5 of them. And rep range is the range on the replication sheet to summarize. Okay. So we set this rep range to this particular range on the replication sheet because we already selected a replication sheet. And then we go ahead and go to the summary sheet. With this range, we print out a bunch of summary statistics. We use the Excel's function to calculate summary measures and put them on the summary sheet. Okay, so the Excel functions are min, max, average, standard deviation, median, and percentile. And we use rep range as the range that we have selected from here. This sub update histograms changes the settings for histograms of simulation data appropriately. Loops over the simulation outputs. For each output, it updates the appropriate histogram worksheet using results from the simulation. So looping over the output measures, we have 5 of them. So we do a for loop. So 4 and then next, so it's over here. So this is a giant for loop. Everything is done 5 times, once for each output. Okay, so the histogram each have 10 bins. The lowest extends up to the 5th percentile. The last one extends beyond the 5th percentile. And the remaining ones are equal length beyond these extremes. So so this is the 5 percentile. This is the 95th percentile. And we basically go to the summary worksheet to select these ranges and their values and save them into 5th percentile, 95th percentile variables separately. And then we define increment as the high end, 95%, and the low end, the values. We divide them and we find the range, and then we divide it by A so that we can get equal sort of size increments. The rep range contains the data for the histogram, so the replications. With this range, what we do is we set the rep range to this offset, right? So the offset depends on the replications that we're doing. And then we use the Excel function to calculate summary measures and put them on the summary sheet. So we calculate the mean, max, average, standard deviation, median, percentile, and so on and so forth. And we put them on the summary spreadsheet. So this is how we collect all the summary statistics. And how do we update the histogram? Okay, so this sub So with the replications, I think I went up there and talked about the wrong sub. I'm sorry about that. So the histogram sheet contains the data for building the histograms. Column A has the bins, and column B has labels for the horizontal axis, and column C has the frequencies for the heights of the bars. So with this histogram, spreadsheet. So we have histogram 1, histogram 2, histogram 3, right? So each one of these is a histogram, numbered histogram. And then we'll do the offset, and then from 2 to 9, we basically will get the value of these. We will calculate these using the percent, the 5th percentile with the increment, right? And we'll be able to figure out all these different values. And then we set a bin range object. It's the range of upper limits for the bins. They are the values in column A of the relevant histogram worksheet. Excel's frequency function is an array formula or an array function. So the appropriate property is the formula array property. To use an array function manually, you will need to highlight the range where the frequencies are placed, type the formula, and press Control-Shift, Enter. Okay. To do this in VBA, you specify the range where it'll be entered and then use the formula array property. It is not enough to specify F, rep range.address in the first argument, because this range is on a different worksheet from where the formula is entered. It must be qualified by the worksheet name or a code name. Bin range specifies the range of upper limits for the bins. They are values in column A of the relevant worksheet, and we talked about that over here. Okay. So that is basically what this formula is about. It's really about selecting a range using a formula array. Okay, this formula array is basically a range of values. And we do use the replications exclamation sort of notation to specify the code name of the worksheet for rep range. And finally, we have a sub called view change inputs. This sub runs when the user clicks the view change inputs button on the simulation sheet. It unhides, right? So inputs worksheet is usually invisible. So what we can do is we can do dot visible equal true and then activate the inputs worksheet so that the user can view or change them. So hopefully you can see that none of this code is actually the simulation itself. This is all sort of logistics, trying to get this worksheet to be calculated, to be populated, to be shown. And it generates histogram based on the simulation results, but none of this is actually the simulation itself. The simulation itself, it's actually all sort of programmed on this spreadsheet, the model spreadsheet. So the model spreadsheet has a bunch of numbers to begin with. So ending cash, ending value of stock owned, cumulative gain or loss, lowest stop price, highest stop price. These numbers are, let me see. These numbers as you can see, this is from J to J is over here, 265. Okay, so 265 is this number, 109673. Okay, so that's this number. So all these numbers are sort of outputs from last simulation. So whenever the simulation is done, the ending numbers are captured here, and they become the input for the next round. Okay, so the simulation is basically implemented in these two columns, shares sold and shares purchased. and the formula. So if you click on the cell, you can see the formula over here for shares purchased, and for shares sold, you can see the formula over here. That's sort of a very daunting formula. So what I want to do is I want to show you how to read the formula. So this is the buy low and sell high strategy. So buy low meaning that you're going to buy some shares when the price is dropping. And this is greater than 0. This is sell high, right? So if all the changes are negative, then you will actually sell. So I think this is sell low, actually. If you think about it, this is when the prices are dropping over time, then you should really sell low. This is, oh, I'm sorry. This is sell. This is buy low. Okay, and this is sell high. So you're trying to sell here. Okay, so the formula for shares sold is printed here. Okay, so this is basically the formula over here, and I just copy and paste it into this text box so we can kind of analyze it. Okay, I've color-coded everything so you can see how they are, how they correspond. Okay, so this code basically is saying that if all three of these conditions are met, right? So all three of C14, C15, and C16. So those are this number, and this number. So these changes, if all three of them are positive, meaning that this is, if you look at this number, this is basically today's price minus yesterday's price. So if the price has been going up, then this number will be a positive. So the change from previous day will be positive if the price is going up. If the price is going down, you will get a negative number. So if I look at these three values, if they are all positive, that means the stock market has been going up for 3 days already. What I'm going to do is I'm going to sell. Okay, so sell using this percentage for 3 days in a row, and that sell percentage 3, actually it's the name of a range, and that range comes from this inputs spreadsheet. So this is by percentage 3. So if you can see it over here, this is if the price has been going up for 3 days. Then we're gonna, well, this is when the price has been going down for 3 days, then we'll buy. This is if the price the changes have been positive for 3 days in a row, then we're gonna sell. So this is what we call sell point 3, sell point 2, percentage 2, which is if the price has been going down for 2 days in a row, then we'll sell this much. So this percentages, right? Sell percentage 3, sell percentage 2. These numbers come from inputs. So those are the ranges that we are looking at. It's coded in red. And when you come back to the model, you will also see these values. So red, because they come from the red portion of inputs. We multiplied the percentage by D16, which is the blue column, which is the beginning shares. So how many you have, you're going to sell them. Okay. So this is the number of shares that you're going to sell. If there are only 2 days in a row that are, the last 2 days are both positive changes, then you're going to sell the percentage for 2 days in a row. So sell point 2 is the sell percentage for 2 days in a row. And then we're going to time that with the beginning number of shares. Okay, so if changes from the last 3 days were all positive, then we'll sell this percentage of beginning shares. Beginning shares is this blue column. Else if, right, so if this doesn't qualify, then we're going to see if changes from the last 2 days were all positive. If they were, then we're going to sell this 2 day sort of percentage of beginning shares. Okay, so beginning share comes from here, and the percentage comes from this input spreadsheet. Otherwise, this column is going to be 0. So that's what this last little 0 here means. Okay, so that is our sell high strategy. Now, our buy low strategy is very similar in the sense that the highlights are, they are the same. The only thing that's different is that we're looking for drops or changes that's negative. So C14 is change from previous days, less than 0, meaning it's negative for 3 days in a row. Then we're going to start buying. Okay, so the buying part, so if changes from last 3 days were all negative, then we're going to buy this amount of beginning shares, or sometimes I don't have enough money. So what I want to do is I want to check how much cash I have, beginning cash, and I divide it by the beginning price of the stock. That way we can know how many stocks I can buy with my cash. So I want to check this number, and whichever is smaller, that will be the amount of changes, the amount of stocks that I need to buy. Okay. So we check whichever is smaller, we'll take the smaller number and go with it. Why is it whichever is smaller? Well, because of this min command. Okay, so it's purple here and purple here. This is basically what we have implemented. We implemented a min command that tells us, look at this number by percentage for 3 days of drops times the number of shares, right? So that will be the beginning shares is blue. Or we'll try to find an integer of the ratio between H16. So H16 is over here. That's the beginning cash. And the beginning price. Okay, so we can see the beginning price of the data set, and we'll choose whichever that's smaller. So again, that's a function of this min command. Okay, else if changes from last 2 days, so we'll look at the percentage for the last 2 days of beginning shares or beginning cash divided by beginning price, whichever is smaller. So we have 2 different ways to determine, and then we have to pick the smaller number because sometimes you just don't know if people are able to train the homework. Right? So, well, we don't know if people actually have enough money to buy the stock, so we want to make sure that there's enough cash in hand to buy the dedicated price. So that's all. That's a walkthrough of the code and the key formulas that are being used to simulate the stock market. So hopefully you enjoyed this presentation, and hopefully you'll be able to understand the code a little better. And I definitely encourage you to mess around, play around, change different numbers, and see what happens. Hopefully you'll feel a little inspired and get some new ideas for your team assignment project as well. So good luck. Feel free to come to office hours or send me emails about your questions. See you next time.